So this is also, I think, straightforward and should be done in the first go. So let's try to construct this matrix. So any entry, the ith rows, jth columns entry would be 1 if j plus 1 is divisible by I. So this is the first row, and as every number is divisible by 1, each entry would be 1. For the second row, the first entry would be 1, the next would be 0 followed by 1, and for the third row it would be 0, 1 and 0, because obviously for this j is 1, so 2 is not divisible by 3. This is j is 2, so j plus 1 is 3, which is divisible by 3. For this j is 3, j plus 1 is 4, which is not divisible by 3, and so on. So we have our matrix M. Now let's start with option A. This is 1 1 1 1 0 1 0 1 0. So as the second and third column added gives us the second and third row added gives us the first row, that is r1 equals to r2 plus r3. So the matrix M is not invertible. Determinant of M is 0. So A option is wrong. For B option, this is A1, A2, A3. Let's try to find all the constraints we can on A1, A2 and A3. First we get is as this row times this column, this vector should be A3 minus A3. We get that A2 is minus A3. So we'll just replace this with minus A3 and this becomes A3. The next thing we get is from this row and this, we get A1 plus A3 is equals to A3, which gives us A1 is 0. Yeah, and that's all, because when first row is multiplied by this vector, we'll get 0 equals to 0. So yeah, with all the possible values, non-zero values of A3, we'll get this column vector, which non-zero column vector, which satisfies this condition. So B option is correct. C option, mx equals to 0. Okay, we need solution for this. So again, this into this row into this vector will give us y equals to 0. This row into the vector will give us that x plus z is 0. So let's write like this. Yeah, now for all the non-zero values of x, for any real value of x, we'll have this into this is 0. So for all values of x, this form of vector multiplied by this matrix will be a 0 column vector. So C is also correct. D is m minus 2y. So m minus 2y is minus 1 1 1 1 minus 2 1 0 1 minus 2. Let's see this. So again, notice that R3 plus R1 plus R2 equals to 0. That gives us that the matrix is indeed not invertible. That is, m minus 2y's determinant value is 0. So D is not correct. So answer is B and C.